Okay, we want to find the length, the arc length of this function right here between 1 and 3. What we're going to do to make this easier on ourselves is we're going to actually take x and we're set it equal to y cubed over 3 plus 1/4 y to the negative 1. This is actually going to be a big thing later on. Okay, so since we're doing a function of x with respect to y, we got to use this equation. So I need to find dx dy. So in other words, I need to find the derivative of this with respect to y. And that is actually going to be, well, this is going to be y squared plus, now this negative is actually going to make this negative right here, 1/4 y to the negative 2. So there's my derivative, and I'm going to plug it into this equation right here. So L, in this case, is going to be the integral from 1 to 3 of the square root of 1 plus y squared minus 1/4 y to the negative 2 squared. And then that's going to be with respect to y. Now, let's talk about this really quick. Well, if I take y squared minus 1/4 y to the negative 2, and I'm going to square this, that really means that I'm going to take this and multiply by itself. So then I get this times this, which is y to the 4th. And then I get this times this, which is actually going to be negative 1/4 y to the negative 2 multiplied by y squared. Well, I'm going to add these exponents, so I end up getting y to the negative 2 times y squared, which is going to be negative 1/4 y to the negative 2 plus 2, which ends up being y to the 0. So this is just negative 1/4. So we're going to get negative 1/4. And then we are going to add it to this one right here, which is the same thing. And then I'm going to add it to this one right here, which ends up being negative 1/16 y to the negative 4. Okay, so if I combine like terms, I end up getting y to the 4th minus 1/2 minus 1/16 y to the negative 4. I'm going to leave it like that just to make sure everything works out fine. So if I actually plug that in for this up here, I end up getting, well, L is going to be the integral from 1 to 3 of the square root of 1 plus y to the 4th minus 1/2 minus 1/16 y to the 4th, and then dy. Combine like terms, so I end up getting the integral from 1 to 3 of the square root of 1 minus 1/2 is just 1/2. The y to the 4th stays. And then I get, oh, shoot. I messed up. Negative 1/4 times negative 1/4 is positive 1/16. I'm sorry. I totally messed that one up. So this is plus, and this is plus. So this is 1/16 y to the 4th dy. Now, if we know our perfect squares, if you remember, a plus b is going to be a squared plus 2ab plus b squared. And then a minus b is a squared minus 2ab plus b squared. Now the only difference here between this one and this one is this middle sign. And if you notice right here, the difference between this right here and this right here is just this middle sign, which means if this is this, then this inside here is going to be the same thing but with an addition inside, if you see the difference here. So it's going to be y squared plus 1/4 y to the negative 2 squared dy. And then this reduces with this, and you end up getting the integral from 1 to 3 of y squared plus 1/4 y to the negative 2 dy. And if I integrate this, I end up getting 1/3 y cubed plus, that's going to be minus 1/4 y to the negative 1, evaluated from 1 to 3. So if I plug a 3 into here, I get 27 divided by 3, which ends up being 9. And then minus 3 over, so it's going to be, this is going to be 1 over 3, and times 1 over 4, which is 1 over 12. And then we need to subtract that with 1 plugged into here, so that's going to be 1/3 minus 1/4. And if we combine everything together and we actually set everything with a denominator of 12, this is going to be 108 over 12 minus 1 over 12, and then minus 4 over 12, then plus, because I distribute the negative, 3 over 12, which ends up being 106 over 12, which equals 53 over 6. That's it.